Now we have a variable as well, right? Now we have a rider variable. How to extend that? The same logic only. So we can say extend int rider, and then I can use that rider. Rider equal to, okay, maybe we can say that equal to 0. Rider plus plus. Then value of rider is right now. So maybe we can even try this by giving some other value. Rider equal to 10. And then in extend main.c, we are not going to initialize that with 0. Just increment and print. That makes sense now. So let us see whether they are bringing the old value. That means the initial value that we gave. We get an error. Each undeclared identifier reported only once for each it appears in. Okay. Error undeclared first used in this function. Okay. In line number 22. I think there is a typo. Rider undeclared. Here I have one more thing. It is compiling. Now remain. See here, it remembers the initialized value that we have in that module, and
Yes,
simply update that its value. That's it. Got it now?
yes.
So that's how it is. This is how you have to use extern. Now we are clear about extern modifier. Then the static modifier. I believe static modifier we had seen in CAPL, we had seen in, I don't think we had seen in Python. We don't have something called as static. In CAPL we have static. Every variable in CAPL is static. Let us realize when we can go for static, and what are the capability that we gain when we use a static modifier. Using an example, first thing is I just create a module sta stat.c. Here as include stdio.h void main of we have a variable here static int. Maybe first we will do that in simple way. Int rise void function f call counter, function call counter. it is the function name. What this function will do, it has a local variable called static int call counter. It is initialized with 0. Call counter plus plus print the function is called time. Right? So this is more straightforward example. So what I do, I just call it here. Want to prototype that here. Right now. So now just I'm going to run this program. But this will, I will get an error here. So I can say +1 because we have the value from 0. GCC stat.c stat. Stat is not recognized. Okay, sorry. GCC stat.c o stat.exe stat. Function is called 2 time. Function is called 3 time. All counter 0. We increment that. Okay, I believe, sorry. This is not required. Here itself we increment, right?
Yes, sir.
Right, so that we don't need that one. Right. So function is called 1 time, function is called 2 time. Okay, so but if you look at this function, when it is called here, what will happen? Program counter will position its load the value to the program counter, that the address of this function will be loaded to the program counter. From here they will execute. If you look at this function, the first statement is call counter is initialized with 0, and then they increment the value by 1, right? Then they print that value right now. But actually what we have to get is, when we enter into this function, they have to execute this statement first and have to initialize the call counter value to 0. If the call counter value is 0, initialized to 0 every time, or every time we will print like function is called 1 time. That means function is called 1 time will be printed 2 times. That's it. But it didn't happen. What happened is, when we call the function first time, they print it is called first time. When we call it again, they printed it second time. How that works? What made that to happen? Come on.
Sir, can you repeat once again, sir?
Actually, usually the function calling and how the function will work, if it is called in a main, means when they encounter a function call, the program counter will be positioned to beginning of that function. The beginning of function is starting from line number 14, where we are declaring a variable called call counter and initialize with 0. And then we increment the call counter value by 1. So call counter is 0, incremented to 1. Function is called call counter time means 1 time. That will be printed if we call this function. Agree?
Yes, sir.
That is what happens when we call first time. When we call the same function second time, we get a different result. What we are getting is function is called second time, which means that they ignore this line. They simply increment the call counter from value 1 to 2 by remembering the old value, and they are printing it is 2 times. If you call 10 times, it will keep on saying like 1 time, 2 time, 10 time, like that it used to go. Why that happens?
Because we are using the keyword static, sir. So once the variable is created, so next time again it will be again it will be not created. So it will
Okay,
use the
so
old value.
static keyword is used for permanent local variable creation.
Yes, sir.
Sir, if I don't use this static, what will happen?
So again every time uh,
Moment they enter inside this function, they will create this call counter in stack memory.
yes, sir.
Right now, they will go and create this in stack memory, and it'll initialize that with value 0. They increment that call counter by 1 so that the call counter will become 1. When they print function is called 1 time, they will print. The moment moment they reach the end of this function, this memory allocated in the stack will be deallocated. The lifetime of function, this variable starts here and end here. So this is like volatile or a temporary variable creation.
Yes, sir.
Or temporary local variable creation that happens when we don't use any storage modifier, because they assume auto as a storage class and they store that in stack. So when we include the word static, it is a permanent creation but not in stack, because when we create something in stack, it will be deallocated automatically. That's why they are declaring this variable outside the stack. Right now, it's also in RAM, some memory location in the RAM. But the moment they created, that's all. They won't come to that point again. Even you can call 1,000 times, no problem. Once created, they will only work with the rest of the instruction that we have. So the
Yes, sir.
redeclaration and reinitialization doesn't happen when we use static. But the
Yes, sir.
problem with the static is, see, as I told, as they are creating only 1 time and it is appearing in the RAM, it means it is permanent as long as the RAM is powered. Right now, as long as I have my laptop in on state, that variable is there in the RAM. X or no? It is there in the RAM, no?
Yes, sir.
Right now, it is as long as I turn on the power, I keep the laptop in on state and the program is running. Not program is terminating, the program is running. Program is not terminated, it is running. As long as it is running, the call counter variable is there in the RAM. If that is the case, can I use the call counter here? Because it is permanently created, no?
No, sir. It is local variable.
Local variable to what?
So the function f
F
call
call count.
count.
F
Yes, sir.
call counter right now. So the scope of static variable is the function in which it is declared. If I declared this particular static variable here in main, I can use within main. If I declare in a fcall counter in a function, I can use there. If we want to do a global one, let us try that, declaring it here right now. We can declare like this, right? So now as long as program runs, any function in this module can access it. Yes or no? Right now. So let us try that. I increase the call counter here one time. So now it is in a global scope. I can use it within this function wherever I want. Within this module, sorry, within this module means within this file. I
Yes,
can
sir.
use it anywhere right now,
Yes.
right? Let us check that. See, here it is modifying from initially they called, while calling it becomes 1. Then in the main we increment that by 1 so that it becomes 2. When we call second time, the 2 become 3 and it is printing 3 times. So the variable is available now as long as program runs.